that. Nope. Good evening, everybody, and welcome to Advanced Refrigeration Podcast. You're the host, Brett Wetzel and Kip Compass. I see you're at home, so what are you doing?
I've been doing safety trainings for the last 2.5 hours, trying to,
How's that going?
Not good. I'm ready to smash the iPad and just quit.
That's every week, though.
Yeah, not when there's 30 of them they want done today.
See, I was always real bad about that. I was like, yeah, I'll do it. And then before I know it, I got a bunch of them that I need to, catch up on.
Yeah, on top of everything else we have to do. So I've been piping cases and trying to help the fitters get caught up. And then I'm about to jump back into startup land here pretty soon, hopefully.
Yeah. What were you helping the fitters on? Are you working on that hot gas thing, or are you?
No, we're piping cases, like just putting new cases in. Like today I pulled wire all day. I pulled cables through a ceiling that was probably on its 43rd remodel, and it was just, there's just everywhere. Like you can't even make it look nice. It's just I ended up just taking an 1 5/8 90 and throwing it around a pull string and just whipping it through the ceiling and trying to hit as many pull rings as I could, because there's just it looks like spaghetti Armageddon octopus, like Ethernet cables crisscrossing every which way, lines going people gave up on this building 20 years ago. So it's just, you know what? I'm just trying to make it where it's not going to rub against anything, and whatever's the easiest way possible, because this drop ceiling ain't never coming down.
Sweet. You didn't buy the crossbow yet, where you can actually just hook the pull string up to it and just shoot it up over the rafters and pull it out?
I would be afraid to shoot it in this building, because there's it's like a rat's nest of Ethernet cables and other cables and sprinkler lines that are above the drop ceiling, because the drop ceiling used to be 10 feet lower, or 10 feet higher. So there's like double drop ceilings, and you can't really get to the bar joist because, yeah. And at one point there was 3 ceilings. So you just literally are just like, there's nothing you could do at that point.
It's awesome. Sounds like you're having a blast.
Yeah. So that was my day. And yeah.
Nice. So I'm in Philly.
You.
Yeah, I know. So I was at a meeting, and then all of a sudden they're like, what time do you have to be back? And I was like, oh, we got to record at a certain time, so I got to be back. He's like, you need to leave now. And I did the time difference backwards. So for some odd reason, because I can never get it straight in my head, I'm like, yeah, I need to be back by 4:30 so we can record at 5:30, forgetting that it goes the other way. And regardless, they were like, you need to leave now. I'm like, why now? Because if you don't leave now, you're going to be stuck in traffic on 95 because they're having another Phillies game tonight. I don't watch baseball, so I have no idea. I just knew that something was going on with the Phillies, because probably, I don't know, a quarter of the plane all had Phillies gear on. So, yeah, so that's what I'm doing. Hey, tonight we have a special guest, Denny from Copeland. He's going to come and talk to us and school us on some, I think, CC200s. And I think he's going to talk about the E3 a little bit. I met Chris when I first started working for CoolSys. Whenever I first started, worked on a neighborhood market together. It was amazing. But let's go bring him in. Hey, Chris, how you doing?
Hey, Brett. Hey, Kevin. How's it going?
Good.
Doing pretty good. Just here in Bentonville, hanging out in the office.
You live in Bentonville, right?
Yeah, that's right. Yep, I'm in Bentonville, Arkansas. I'm attached to the Kennesaw business, reporting and team-wise, but yeah, I'm here in Bentonville, and we've got a small team here of controls and support people.
So how long have you worked for Copeland?
So I started in 2014. Of course, we were still Emerson at that time, so this is year number 9 for me, and was doing customer support and application engineering type work back then, and met you on a job in Texas on the Walmart neighborhood market doing some case controls. And so I spent basically all 9 years working on a mixture of case controls and rack controls, and most recently been working on a new case controller development for us called CC200.
I
was
think
funny.
I did one of the very first starter for you. I think we did that store in Illinois. I forget.
Oh, I can't forget DeKalb, Illinois. Yeah.
Yeah, wonderful DeKalb, Illinois.
Yeah. That was a fun. It was a little challenging for me. There were some programming issues when I arrived. I didn't really know what I was walking into, but luckily you were there and I could call in back to the office for a little support. But I do remember DeKalb, Illinois.
Yeah, that was
Yeah, it was a little touch and go for a little while, but
it was there was rack change outs in the middle of the night. It was just glorified fun.
it was Climate Pros, I believe, right?
Yep.
Yeah.
I was actually, we were talking about reminiscing on jobs. I was telling someone that I've never adjusted superheat by bending distributors before in my whole entire life. We had the case, it was no one's fault. They designed it with the two coils left to right on the Kaiser cases for these little end caps, and they only had one expansion valve. So like one would overfeed and the other one would ice up and the other one wouldn't, we get high superheat. And then, so we're there bending it. It was like, well, if we raise this one a little bit more, maybe more liquid will go over to the other side. And that's what we're doing to try to get the damn cases even.
Oh, I remember that very well. That particular customer was very aggressive on pursuing electronic valve control and stepper valves. And even at that time, the industry wasn't quite ready yet. The stepper valve sizing that was released at that time, in my opinion, was not ready for cases because we had the smallest valve was an SERA and the AA wasn't out yet. But we had SERBs on cases, and yeah, it was a little rough for a while. But,
So I had the discussion with Sporlin. I was like, how comes you guys don't make an SER AAA? Because a lot of times with some of these other cases, that let's say a Hussman case, and I'm only using that for example because they have individual coils. Those are only 2,900 BTUs. So if you throw on with CO2, you throw on a SER AA. Now that valve is basically almost 3 times the size of what it needs to be. So during startup, you just have to be aware that you need to limit the max opening percentage just so it doesn't end up hunting real bad.
yeah, I agree. I totally agree with that.
I don't know. Let's get into it. You have a presentation or something you want to show, or how
Yeah.
you want to do this, boss?
Yeah, I got some slides. I figure we'll do a little product intro and then show you guys the Cold Chain Connect mobile app, and then show you some E3 integration to the CC200. And then, of course, hit me with any questions you have.
Cool. So if anyone's not aware, the CC200 is basically the predecessor of the CC100. Those CC100s did not have pressure transducers. They essentially checked the superheat versus the temperature of the distributor tubes and the suction line to basically calculate the superheat. Actually, I think that was the first controller that I made a trainer out of, actually.
I remember you telling me that when I met you way back in 2015 or 16.
I made it back when I was in Connecticut.
When you were talking super trashy.
I'm still talking super trashy. Oh man, it was bad today. It was really bad today. All right, there we go. Oh, nope, too much. There we go. That'll work.
Yeah.
Go ahead, Chris, take it over.
All right. Yeah, like you mentioned, CC200 is a whole new product for us in the case controller catalog. You're probably familiar with some of the other case controllers already, XR, XM. This product is completely new and builds above the feature set of XM in terms of capabilities of what it can do. So it's new hardware, new software, and the components here on the screen, what we're seeing is we have the main controller, the expansion module, the display, and the Cold Chain Connect mobile app. Some of the features, and I'll go over those a bit more, is this controller can do stepper valves, pulse EVs, and an EEPR if the customer specifies that. We have these expansion modules that plug into the side of the main controller, and that allows us to control from 1 to 3 EVAPs. So really easy to expand out for some of those OEM customers that are doing modular coil case design, or if we're doing a walk-in cooler and we want to, sometimes the dairy coolers have multiple coils that might be defrosting at the same time, we can expand out to do multiple cooler coils as well.
Are we sharing a pressure transducer for this, or do they have each individual?
That's a good question. We can do it both ways. So there's a parameter in there where you select, is it one per case or one per coil?
Okay.
I've seen it done both ways, so we support it both ways.
One other question, because I'm not seeing it unless I'm just blind because I am getting older. Fuses. Are there any fuses?
We do have one main power fuse, although I've yet to see one blow, but we do have one on the bottom left here that's a little glass fast blow fuse down here.
But the
So no-
evaporator contacts aren't fused, or the solenoid contacts.
All the relays are Form C, and I can show the ratings if we get into the tech specs a little bit later.
No, you're fine. Sorry.
Some of the other stuff I was going to mention is all the temp ranges plus the dual temp case designs are supported in terms of the set point shift for air temp and pressure SST if an EEPR is being used. We do have good support in here for CO2, and coming soon, A2Ls as well. And then I can't forget Bluetooth. So this is our first case controller in North America to have Bluetooth, and we're really excited to bring that feature to a case controller. Obviously, the industry's going that way with more connectivity and being able to use a smartphone. Technicians are using tablets and smart gauges and pressure sensors more and more. We had to get in the game with Bluetooth.
So you said you're making one for A2Ls. Does that mean it's going to be a little bit different than that one because of the flammability and that?
Yeah, it'll be the same exact controller, but we will swap out some components on the board to get through the UL approvals. So we already have approved components. It's just, we just have to basically rework the relays and release an updated rev of the hardware to get that UL approval. And then it'll be a software update to do the mitigation and gas sensor tasks that are required for UL 2-89. So a little bit of software and some hardware swap on the relays for A2L compliance. So I'll go over some more features here. I mentioned the Bluetooth, pulse, stepper, and EEPR, all from one part number. We don't have any other case controller right now in the catalog. So this kind of brings all those features together in one part number. We feel that's an improvement for us because then you only have one part number to train on, one SKU to keep track of, instead of training across multiple part numbers and worrying about how many pulse, how many steppers do I have. Some manufacturers split it up by coil. So this does 1 to 3 coils, all the valve types, all from one part number.
Could you have a pulse valve on one output and a stepper on the other output?
That's a good question. Right now, that's only supported if the scenario is pulse EEVs and stepper EEPR. Right now, we don't mix and match expansion valves. Currently, it's all pulse or all stepper on the EEV side.
Does that not mean that you can't have pulsing EEVs with a bipolar EEPR?
We can do that. That is supported. I have a chart that shows that coming up here. And the importance there is, and you'll see it on the valve layout here in a moment, is if we do have a customer that wants to use EEPR, they can do pulse, expansion valve, and EEPR on the main controller all in one without purchasing any expanders. Another change up for us is being able to power everything through those side connectors with a single power supply. So if you've ever seen, control trays with multiple valve drivers and the main controller, sometimes there's wiring between the main module, like 2 wires for power and 2 wires for comm to hook all those modules together. So if there's space in the tray, you just line these up on the DIN rail and hook them together, and that eliminates 2 points of power, 2 points of comm for each module, cleans up the tray, not having those cables going from module to module. Good little improvement there. We've got some color-coded temperature and pressure inputs to match our sensor insulation color. So that's another handy improvement there on the hardware.
That's the same thing for the pressure transducer, if I'm not mistaken, for what I'm making out in the picture, right? Because you have black, white, and red.
Exactly. Yeah, that matches our wire harness for our standard pressure transducers.
Now, what about the valve layout? Do you guys have a pretty clear cut chart on like different manufacturers, whether it's Sportland, Copeland, Danfoss, of how to wire the EEVs? Because I know that's always been an issue in the past.
Yeah, exactly. So right now we have a chart in the manual that shows the approved valves and also shows exactly what pins on the stepper terminals to land everything. I'll say the North American market is pretty heavy Sportland Danfoss. Right now our approved valve list is heavy on Sportland, but we're looking to add more Danfoss on the stepper valve side coming up. And then on the pulse valve side, we're good to go there for pretty much any 120 volt pulse valve, and then I come across too many 24 volt valves, but we do support 24s as well.
With your guys' pulse valves, are you guys using external SCR relays to do them, or it's all driven inside of it?
Yeah, it's all built in. I'll show you a terminal layout that shows that, Kevin, but yeah, it's all built in on the board. With some new software features, we totally revamped and reinvented our EEV control algorithm, specifically testing it for different compression types in our labs, and specifically doing a lot of testing around CO2, because CO2 is a bit more volatile on the pressure fluctuations, and up to this point, it's basically EEV control, does air temp, then you got to watch the superheat as well. All new EEV control algorithm. It's performed very well in the lab, very well in pilot storage as well. We've got about 1,600 of these controllers out there in the States currently. Probably, I'll say the majority of them are synthetic refrigerants, and we've got some of those running CO2. I'd say probably 5 stores or so that I'm aware of with CO2. On the CO2 side, we recently added support for ultra low superheat. A couple OEMs are trying that out. Kaiser EPTA specifically has their ultra low superheat rack design, so we're able to be compatible with them and any other OEMs that are doing that.
So before you go off on that, I just want to ask a question. So is it an input that selects it, or is that something in the software?
So right now it's done through E2 or E3. Where?
All right. So if it goes into FTE or EPTA mode or whatever, ETA mode, the controller internally can tell that case controller, hey, that medium temp is typically 6 to 8 degrees, but I want to knock it all the way down to 1 to 3 degrees or whatever.
Exactly. Yeah. As soon as we get that communication, we make the shift, and case controller just goes right into ultra low superheat mode. And then we have some safeties built in there. If it were to drop offline, or if it were to sense that E2 or E3 isn't there for a specified amount of time, then it'll go ahead and exit out of FTE mode and go back to regular superheat.
Will it say that on the Bluetooth when you're pulling it up?
Yeah. So there's a mode of operation along the top, and it'll indicate, instead of saying normal refrigeration mode, it'll say superheat optimization mode is what they ended up settling on. That matches the XN naming. They will both say the same mode on E3 and then the mobile app as well. I thought I'd give you a little walk around the hardware and then go over some specific features on the hardware before we jump to a demo. Kevin was asking about that external solid state relay earlier. On the top left, we have a triac built into the board that does the switching for the pulse valve. Have the configurable period of control. It defaults to 6 seconds, which is kind of your standard right now. So that's where we handle that pulse valve, is top left on that connector. Along the top, we've got 5 relays. 4 of them are predefined for fan, defrost, lights, and refrig. And we have 1 auxiliary that can be programmed as a backup for any of the 4, but that can also do some additional functions. One of those additional functions is it can be a satellite for E2 or E3. So it can, if we put it in satellite mode, it just becomes directly controlled by E2 or E3. So anything you link it to, any flex combiner you link it to, it will just listen to whatever E2 or E3 tells it. Also on the relays, we have the integrated fan CT in the fan RO circuit. So if you hook up the fan circuit on the cases directly, we are able to monitor the amperage of the fan circuit. And we've tested this on multiple motor types, and the ECM motor type was a little tricky in the beginning, but we tested on ECMs to be accurate all the way down to sub 0.2 amps, like down to 150 milliamps in that range. Very accurate. It works well.
I mean, the defrost heater CT is, that thing's killer. If they actually use that the right way, and I would save so many in the middle of the night for those calls.
Yeah, we're trying to encourage retailers to use that. We have an input for that along the bottom, and what we basically generate 2 main alarms based on that. So we'll tell you, hey, the heater was supposed to be on, it didn't come on. That's 1 main alarm. The other one that we do is we look at that, and we look at temperature-based termination. If we see that a defrost was set up for temperature-based termination and it did not terminate on temp, we will throw out a fail to terminate on temp alarm, basically saying, hey, you were supposed to terminate and you did it for some reason. So those 2 alarms are very powerful if they're used the right way and taken seriously, like you said.
There it goes. Keeps keeping me out. The do not terminate alarms, yeah, or did not terminate alarms are great, but they've always had that nuisance there. But you add that defrost CT in there, and especially the electric defrost, and you're basically stopping all those midnight service calls.
Yeah, that's the hope. Moving along the bottom here, we got some digital inputs that are all flexible, where you just define a purpose for those, so like door switch. We've got some clean switch input. We've got a leak detection input for customers that use leak detection systems that want to do a shutdown. We got our pressure inputs down here for the suction pressure transducer. And as Brett pointed out earlier, it's color coded to our Emerson Copeland pressure transducer harness. And then your standard temp inputs, green for the discharge, orange for defrost term, and purple for return air.
No, is there? Oh, sorry.
I was going to say the coil out's not colored here because we have customers using red and blue, but coil out goes right here next to return air. Yeah, go ahead, Brett. You have a question?
No, I did, and then I just lost it. Oh, that happens. No, Wizmate. Do you have to use Wizmate with this to get access to all the other secret stuff, or
no?
Is everything configurable via the Bluetooth?
No, I'll show you here in a little bit that everything is very congruent between the mobile app and E3. So actually, Wizmate's not currently supported, and we're doing everything through E3 in the mobile app at this time.
Oh, that's different. That seems a lot easier.
Yeah. It seems small, and I'm sure like guys like Kevin will probably appreciate it. It's like we put a lot of, I'll say, effort. We probably spent more time than we should have talking about what should we name the parameters and how should they be organized. And we put everything in the same name on E3 as the same name on the mobile app. The same group tab on E2 and E3 is the same group tab on the mobile app.
See, that's killer, because like that was always the problem with Wismate and the Dixel stuff, and everything had different names, and right there is killer.
Yeah, we realize that. And like you said, if you're getting a call at any time of the day, time is valuable, service time isn't cheap. And so we really try to avoid the scenario of three-digit parameter codes, look it up, what does it mean? And then we had the E2 name in there. We realized that we wanted to do something different with this product. And so that's what we did. Okay, so moving on the bottom here, the temp inputs, we got one input for defrost CT, which is exactly what Kevin was talking about. We sell a CT that's 4 to 20 milliamp to get maximum accuracy. You just wire it off this plus 12 volt power tap and then over into the defrost CT input. We have two auxiliary inputs as well. Those can be satellite for E3 or do some other functions as well. I forgot to mention the RS-485 ports up here. So this is where we're going to do BACnet Modbus. And then coming very soon, when A2L support rolls out, we will have a A2L refrigerant sensor communication tapping off here. And then last but not least, the stepper valve. So bottom right, stepper valve connector, so you can run a stepper EUV for your expansion valve, or if the customer wants it, you can do an EEPR. So that's the main controller. Just do a little contrast here. Won't take as much time, but the expansion module is our add-on module that is designed to add that additional evaporator coil or to add on that EEPR valve. We're still seeing case OEMs build modular coil case designs. We're still seeing multi-coil unit coolers. And as long as the amperage and electrical design allows it, we can do multi-evap freezers. Depends on how much they want to defrost at one time. But essentially, you just put this guy on the DIN rail and connect it to the main module, set the dip switch. We've got a little address chart on there. So it's printed right on the plastic. It tells you how to set address 1, 2, 3. And then pulse valve connector up top, stepper valve on bottom, and your temperature and pressure inputs. If the manufacturer is doing one pressure transducer per coil, you plug the additional transducer in here. And then
how many expansion modules can you have up to this thing? Because some Husband coils or Husband cases have like maybe 4, right? And then you have like some Kaiser Warren stuff that has a lot of coils in there. So what's the max expansion modules that you can put on there?
Right now it's 3 evaporators total, and we can do 3 evaps with an EEPR, so 3 total expanders is the max right now. Another tidbit I was going to mention about the pressure transducer, if the manufacturer is using multiple coils and they're using an additional transducer, we have some redundancy built in there where if we lose one of the transducers, it'll fall back to the available one. So little added bonus for those that are using that feature. I'm sure you got some text in the audience. I wanted to mention a couple of things that we had in mind when we were designing the controller. We thought we wanted to do a bunch of little things that all add up in the end, all around the controller. And every connector is pluggable. We all know what it's like to be in a confined electrical tray and needing to swap out a controller, and it's rarely oriented in a friendly direction for you to get your screwdriver in there. So everything is pluggable here, and you know how friendly that is. It's also a bit easier if you need to get a meter lead on something. We also have what we think is descriptive labeling about, hey, this is the stepper valve connector, this is the triac for pulse valve, this is the fan, this is pressure, versus maybe some of the stuff we've done on other items in the catalog has been generic labeling all the way across. With the, oops, sorry about that. With this being refrigerated case controller, we wanted to do everything as descriptive as possible. Another little nice to have is there are no shared common wires for inputs or relays. And that goes across the Form C relays and across the inputs on the bottom. And really what that does for you, it's just a small nice to have on the electrical tray. When you have shared commons on all those sensor wires, you tend to get manufacturers that'll have to put splicing connectors in there and bunch all the commons up and bring one common wire back to a terminal somewhere, versus everything's individual commons, very clean on where everything goes for each sensor. Same thing on single point of power for everything. So we're just gonna use one power supply. It's actually 24 DC instead of AC for this controller. Switching to DC helped us pull off being able to do all those stepper valves, expansion modules in the display, everything on one. So you just hit the power plug down in the bottom left, and then the power is distributed out through the side connectors.
So I'm going to ask you this, but I'm not sure if you're going to cover it later. As far as the, you said about the different grounds, there are some case controllers out there that if you do something different with the transformer, it ends up causing a whole bunch of communication issues. Some transformers, they want to be grounded, some they don't. What's your stance on this as far as Copeland?
Yeah, that's a good question. So our stance is stated clearly in the manual that we want terminal 71 on the power plug to be on the chassis ground in the tray. And we obviously want the chassis to have a good ground, but that's pretty much it. Where our communication ports are completely isolated. We're completely aware of issues that have happened in the past where voltage can get onto the communication network and make its way back to E2. And those problems have been eliminated with this hardware design.
That's sweet. So it's complete. The COM ports are completely isolated from the controller.
Exactly. Yeah, we have Brett will probably appreciate this, but I'll say engineering the controller was definitely a global team effort. I couldn't tell you how many people are involved across all the teams, but in the core group of engineers that designed this controller, there were 2 out of the 4 that actually were here during the CPC days when the CC100 was designed. So that was cool to have them on the team. They were also here through the XM rollout. So those guys are really aware of some of the challenges that came up in the past and made every effort to avert those on this hardware.
That's interesting because I've with the XM 678, 679, that if you would have a shorted valve where it just pulse the voltage, it would go straight to ground and then take the PID board out. But now that I'm thinking about it, like after all the CC100s I've ever worked on, I've never actually once seen that.
Yeah, that was an issue we knew we had to keep eliminated on the hardware, and so those guys did a great job on the electrical design.
So look at the bottom of this thing. It looks like the Dixel board setup. Now, is there a battery adapter on here? Can you, like some of like the iPro stuff, can you have a backup battery on this? So if you were in a shutdown situation, you could close the EVs?
Yeah, obviously the Dixel team is a huge part of our global engineering team, so they definitely were part of the CC200 team. And on terminal 74 and 75, to answer your question, we can hook up the Dixel super cap on terminal 74 and 75 to do that valve closure, like you said, Kevin.
So yeah, that's nice too. I mean, just to be able to get that valve closure, to be able to use separate valves to get rid of the pulse valve.
Yeah, that's what those terminals are for. A couple other things, then we'll move on, is the expansion modules plugging in directly to the main module. It really cleans up the electrical tray. and takes some of the guesswork out of, did I get the power and comm right? Or oops, I crossed the power and comm on one of the modules. And then what we talked about was the Bluetooth chip. Adding that was huge. We had to get Bluetooth on the case controller, and we're happy to get it on this one.
All right, what's the password? Give it up. Give it up, Chris.
Yeah, I'll show you about that here in just a moment.
What do you mean, show me? Come on.
What's the range on the Bluetooth?
I think it's probably 40 to 50 feet. I'll say it's not long range, like 300 feet. It's more 40 to 50 feet. The problem you get into is we're always getting a display mounted in a metal box, and that cuts it down right away. But I haven't had any complaints, and we've used it already on the sites that we have installed. This is just showing you have multiple modules. They go on the DIN rail, you slide them together, single source of power, like we talked about. The power supply that we're UL approved for right now is also DIN rail mountable. So it makes everything nice and clean on the install. I'm going to skip over this one because we covered it earlier and show you the multiple valve layout. So here we have a main controller and 2 expanders. This will be a 3-coil setup where you have pulse valve along the pulse valve connectors, main module, expander. And then optionally, if the customer wants the EPR, you throw that on the main controller. And then, of course, all your temps and inputs go along the bottom. If we're just doing 1 coil, the stuff on the right goes away, and we would just keep the main module. I wanted to talk a little bit about communication networking with the E2 and E3. This controller has BACnet, and we're using a different method than we traditionally have. You've probably seen it on some other controllers out in the market, but this is actually a really good method. We've used this on a ton of installs. And basically, we do BACnet MSTP with 22-2 twisted pair cable to 1 controller, and then we do the BACnet IP with Cat5 cable from that main controller, which we call the router, to all the other controllers. This has a big fringe benefit in that customers that group defrost together into lineups or circuits or defrost groups, whatever lingo you want to use, but customers that use lineups, we're able to do all the defrosting and all the case-to-case communication through this Cat5 cable. The lead case goes out and contacts all of the slave cases and coordinates everything. It's incredibly reliable. It's super fast. It allows us to grab and synchronize a ton more information than we have ever been able to with RS-485.
So is that just every single circuit is RS-485 then Ethernet, or is it just one case gets the RS-485 signal and then everything else is BACnet over IP?
We like it to be one case with RS-485 and then everything else, as many up to 32 additional modules on that with BACnet IP.
Does the E3 support BACnet IP? Like,
yeah.
Oh, so you can just go straight back to the IP and just get rid of the RS-485 completely?
Yeah, and that's a huge reason I was about to segue into, Kevin, is this supporting this architecture now really sets us up to be able to use all BACnet IP, all Cat5 with E3. And so then you just have a Cat5 daisy chain through these dual Ethernet ports back to E3.
I'd imagine it's got to be lightning speeds faster.
Oh, it's awesome. We've done tests in-house I've shown E3 here. We've done tests in-house just doing Cat5 back to this guy on the Ethernet port. And it's so reliable and so fast. It's just a huge upgrade over RS-485.
Now, does the E3 have a dedicated Ethernet port in there that's not on the customer side, or is that something that has to be on the customer's network too?
We can do it both ways, but the easiest, probably pain-free way without dealing with IT and going through all that is to use that spare Ethernet port on the E3. So the E3 has 3 Ethernet ports on the back of the door, one for PIB board and display, one for the customer WAN network, and then one available one, which is where you can hook your laptop or where you can hook back net IP devices. So we'll use that third one to hook up the case controller network.
No, it sounds great. So what if you have a quite a large network? Can you extend that to a router or a small switch?
Yeah, you could hook like a 5-port switch up to that spare Ethernet and then give yourself some cabling options that way. I'll probably get in trouble for saying a number, but I think that we're headed towards being able to support 100 plus devices, 100 plus case controllers. That's our goal. We want to get to that point to make it worth it.
Is there a difference when you're on Cat 5, whether if you're on Cat 5 versus like just daisy chaining them together with a regular communication cable?
Yeah. So the preliminary, we'll say goal number that we're striving towards was for Cat 5 to get to that 100 on one network, one strand. Now, if we were doing RS-45, we can do 32 per port, and then the number you can stretch that across multiple ports to get up, to 90 or however many cases you have in the store.
So I have also another question, and you could not answer this, whatever, but I was just curious. We've seen it some of the stores, obviously not with the CC200. I haven't seen it happen, but on like some stores where we'll see where the temperature basically flatlines, causes a potential high temperature of a case when used with the E3 with certain case controllers. It can happen, I think, with the XM series as well as the Core Link. Is there something out there that you could tell us what's causing that? What can we do to fix that?
I'm not actually familiar with that one. So unfortunately, no. I don't. Yeah, I don't know. Are those Modbus? Yeah, that would be Modbus if they're XM.
Yeah.
I'm not aware of that one.
Yeah, all I know is that occasionally like it'll work, and then all of a sudden it'll just flatline, and it might flatline while it's defrost, so it like kind of sticks with the last temperature it had or whatever, and then it goes into alarm. Well, you get there, the case is down to temp, but the E2 is just showing dead flatline.
Yeah, I'm not. Unfortunately, I should say unfortunately and fortunately, I've been buried into this controller in this project for so long. I haven't come across that one. I mean, if I were there, the first thing I would do is try to recommission it, go into the network summary and knock it offline on purpose, and then try to bring it back online. That's usually, you can unstick some things like that by recommissioning it.